In this lesson, I will be discussing to you our second topic in Math 101, which is entitled the unit circle. We will now begin our study of trigonometry with this topic. Kindly recall how you plot in the rectangular coordinate system or the Cartesian plane. We all know that the center of the coordinate system is called the origin. Since it is a plane or two-dimensional graph, there is two axes here, namely the x and the y axis. Here is a graph of a circle, a unit circle in particular. A unit circle means it has a radius of 1 unit, so the length from the origin to any point in the circumference of the circle, which is called the radius r, is equivalent to 1 or unity. As we plot the points of intersections of the circumference of the circle with respect to the x and y axis, you will observe that the 4 points with the following coordinates: 1, 0, 0, 1, negative 1, 0, and 0, negative 1. The graph is divided in 4 quadrants as we can see in the figure. Now, if we are going to draw an angle, we will start from what we call the initial side and we will end at the terminal side. The ray is rotated in a counterclockwise direction, creating the angle theta. The angle theta is the angle measurement between the initial and the terminal side with a unit of degree or in radian measure. We usually define a convention for positive angles. When we say a positive angle, it means that we will start from the initial side, then move or rotate in a counterclockwise direction. So if you want to draw a negative angle, let the ray rotate in a clockwise direction. As you can see, there will be a point of intersection of the ray from the unit circle. We assign the coordinates for that point, namely a, b, where a and b are called ordered pair, with x as the abscissa and y as the ordinate. What we are doing here is to get the relationship of the unit circle with respect to the traditional definition of trigonometric function. Let us recall the SOHCAHTOA definition, where sine of theta is equal to opposite side over hypotenuse, cosine of theta is equal to adjacent side over hypotenuse, and tangent is equal to the opposite side of the triangle over the adjacent side of the triangle. We will now create a right triangle and make the theta as one of the internal angles of the triangle. Take note that when we say that a triangle is a right triangle, it means that one of its internal angle is 90 degrees. The 90-degree angle is represented by the square box. Now, if we look at the figure, what is the length of the hypotenuse? Take note that the hypotenuse is the longest side of the right triangle opposing the 90-degree right angle. So what is the answer? It is obvious that the hypotenuse is just a radius of a unit circle. The radius of the unit circle is 1, therefore the hypotenuse has a length of 1 unit. Next, what do you think is the length of the height and the base of the triangle? The altitude or height is the opposite side of the angle theta, while the base is the adjacent side of the triangle. As you can see from the figure, the height is same as the y-coordinate and the base is same as the x-coordinate. Therefore, the x-coordinate is a and the y-coordinate is b. Now, what do you think is the value of cosine of theta in terms of AB and hypotenuse? Let us again recall the SOHCAHTOA definition. We will use the ka part, which is defined as an adjacent side of the triangle over the hypotenuse. And since the hypotenuse is also the radius of a unit circle which is equal to 1, cosine of the angle theta is equal to a. It is equal to the x-coordinate of where the terminal side of the angle intersected the unit circle. Next, what do you think the value of the sine of theta in terms of AB and the hypotenuse? We will use the SO part, which is defined as opposite side of the triangle over the hypotenuse. And since the hypotenuse is also the radius of a unit circle which is equal to 1, the sine of the angle theta is equal to b. It is equal to the y-coordinate of where the terminal side of the angle intersects the unit circle. Lastly, the value of tangent theta is equal to opposite side over the adjacent side of the triangle, which is equal to b over a. In summary, cosine of theta is equal to x coordinate where the terminal side of angle intersects the unit circle. Sine of theta is equal to the y coordinate where terminal side of angle intersects the unit circle, and tangent theta is equivalent to sine theta over cosine theta, or y over x. In the next lesson, I will show example on how we can use the definition of the unit circle to start evaluating trigonometric ratios. That's it for now. See you in the next discussion.